Welcome everyone. It's 10:30 Eastern Standard Time, and good morning, good afternoon, good evening to anywhere you guys might be. My name is Anuj Shetty, so we're going to get started today on a webinar that really focuses around big data and the various big data business use cases with the AWS Cloud. Obviously we're going to focus on various AWS solutions. We'll get into some of the various services that they have that focus on big data solutions. Just a bit of housekeeping. So, really we'll go through a very high-level presentation in terms of BlazeClan and introduction to the BlazeClan organization and the team. I'll then hand it off to our technical guru from the consulting side, Varun Rajani, and he'll get into some of the deeper dives when it comes into big data and what we're doing from a use case perspective today, and what we've done internally at BlazeClan for our clients, customers, etc. And then obviously, a deeper dive into some of those solutions. There will be a Q&A, so please do not hesitate to post any questions that you may have into your Q&A window, and we'll address them at the end of the session, and we'll go from there. So just getting on to the next deck, first of all, thank you very much for everybody's time today. Welcome to our big data session today from a BlazeClan perspective. So once again, a quick introduction to myself. I'm Anuj Shetty. I'm actually the Director of Business Development for the U.S. and Canadian operations, focused on really helping client partners understand cloud development and really understand the various Amazon Web Services that we've partnered and evolved into from a BlazeClan perspective. So let me give you some background about BlazeClan. BlazeClan was started and founded a few years ago. We really grew out of a technical operation, an engineering operation, and we really grew out of the focus that 4 or 5 years ago we saw an evolution happening on cloud computing. And one of our strong partners at the time, and obviously still today, our partnership and our strength and our affiliation with them has grown, is Amazon Web Services. So we've basically taken Amazon Web Services and the BlazeClan focus, and we've adopted them in terms of taking different size enterprises, moving them onto the cloud, assessing them onto the cloud, consulting them in terms of their existing application and workloads, and moving them into the cloud. We obviously have a number of clients in various different spaces in verticals, whether it's healthcare, finance, insurance, etc. And obviously with the Amazon Web Service partnership, we continue to kind of grow the business and really help the clients navigate these cloud waters. Obviously, our partnership with Amazon is an advanced partnership, and really our clients continue to ask for Amazon, and we continue to focus our internal skill sets as well as our client focus on the Amazon Web Services portfolio as well. So once again, we'll get into today's focus being one of the Amazon Web Services, and a perfect opportunity to introduce Varun Rajani, who is the founder and president of our cloud consulting business unit. And Varun will take you through the steps, and then I'll come back to the Q&A to make sure that we answer and address any of your questions and concerns. And if there's any takeaways, then I'll reach out to a majority of you post our webinar today, and make sure that any questions that we couldn't ask or couldn't answer in real time, we get back to you. So Varun, on to you.
Thank you, Anuj, for the introduction, and good morning, good evening, everyone, for joining us today for this webinar on big data on cloud. Right. So the idea behind the webinar is to give you guys an overview of what is big data, how big data is basically helping customers across the globe, to find solutions to certain critical business problems. And we would be talking about a few use cases, industry use cases, on how different industries, different companies in different industries are using big data for figuring out solutions or growing their business. and then in the end we'll talk about on how AWS can actually help you in setting up a big data infrastructure on top of cloud, and how you could make use of those services, and we'll give you an overview of what are those services and how do they fit into the whole big data life cycle. So before we start, I'm sure most of you know this, but just to reiterate, we'll just talk about what is big data. Right? Big data, as you know, as all of you would understand, is a term which defines data which cannot be processed by the current tools and technologies. By the current tools and technologies, or the tools and technologies of the previous generation, we mean the limited hardware that we have, the on-premise hardware. When it comes to the software, it's the relational databases that we usually talk about, which do not scale out or scale up beyond a certain level, right? And big data is also identified by three basic characteristics. The three characteristics are it's very fast. The data is generated very quickly. It comes in various different formats, and it's very unpredictable to predict on how much data would be created when, and keep a track of it, right? So that in summary is big data. Typically we talk about the 4 V's of big data. Previously people used to, when we started talking about big data a few years back, the V's were 3 V's: volume, velocity, and variety. But we also add veracity, which makes it the 4 V's of big data. The first V of big data is the volume, of course. As I said, big data is data which is generated in huge amounts, right? In today's date, there is a total of 2.5 quintillion bytes of data that gets generated, which is, and by 2020, that data would increase to 40 zettabytes, and it's too much data to handle using the current relational database services. So, for example, most of the US companies, the Fortune 500, the Fortune 100s, have more than 100 terabytes of data stored on their premises, and it's a challenge to process that data and get meaningful information out of it, and to get meaningful business output out of it. The next V in the 4 V's of big data is the variety of data. So if you are a marketing guy in a company, or if you are engaging with your end customers, a lot of data gets generated, and you need to keep tab of a lot of sources of data. So for example, if you are connecting or communicating with a customer using your web page, you usually will have various social networking icons onto it. You'll probably have emails which are being sent out to your customers. There would be blog pages which would be there for your customers, and there would be a whole other sources of data from which you would get information about your customers, or there would be ways with which you would be communicating with your customers. So all of the data, all these different sources, all these different tools of data generation, or your data sources, will have different formats of data, right? And you need to collate all of that data into one place, interrelate each one of them, and then make sense out of it. So the variety of data which is being generated is vast, right? This is just an infographic which shows on how much data is being generated in every 60 seconds across the globe over the internet, right? So there would be 20,000 plus new posts on Tumblr every 60 seconds. There are 600 new videos on YouTube. There are 1,700 Firefox downloads. There are 6,600 new pictures on Flickr, and all of these things. So the variety of data which is being generated today is it's varied, and it's huge. The next V in the big data V's is the velocity. It's the speed at which the data is being generated on the internet. So if you see, the New York Stock Exchange captures 1 TB of data every day, 1 TB of trade information every day. If you take an example of a car today, the connected car concept, you have more than 100 sensors within your car which collect the data and probably pass on that data back to the car manufacturer. So there are more than 100 sensors in just one car. So imagine the number of cars on the road today and multiply it with 100. So there are more than 100 collection points from one single car. And so the velocity at which the data is being generated, so each car would generate a lot of data at quite a lot of speed. So the velocity at which the data is being generated is huge. The final V in the 4 V's of big data, and which is something that we've added very recently, is the veracity of data. Now there have been quite a number of surveys over the internet and across various organizations asking users to confirm if some data or the data that they are collecting, if it is of any value to them or if it is accurate data or not, right? So for example, there could be bogus comments on your say Facebook page, or there could be spam emails, there could be data which is being generated by some spam, some bots, which is not something that you would require while processing the actual data or while making sense out of the data that you have gathered. So 27% of respondents in a survey mentioned that they were not sure on how much data that they collected was inaccurate, right? And according to another survey or another study, the cost of poor quality of data is around 3.1 trillion per year, $3.1 trillion per year. So that's a huge amount, and I'm sure each organization across the globe is facing such an issue or is losing out on opportunities or is making losses because of poor quality of data. So veracity is again an important characteristic. You need to be sure that the data that is collected is accurate data, is correct data, and is of good quality, which would make sense for your business. Now, big data is getting bigger and bigger and bigger every day. There are more than 1 billion pieces of content which are being shared on Facebook on a daily basis. Walmart, for example, collects 2.5 petabytes of data every hour from its customer transactions. More data crosses the internet every second than we had previously done or stored in the last 20 years of internet history since it started. So big data is getting bigger, and it's even going to get bigger and bigger. Why it would get bigger and bigger is today we are connected in every sense. We use our computers, we use our laptops, we use mobile phones, our tablets, our cars are connected to the internet, our appliances are connected to the internet. There is a whole lot of things that is connected to the internet, and everything is being digitized, and everything that is connected to the internet or is digital is creating lots and lots of amount of data. So, and that is going to keep on happening for for the foreseeable future. The data is going to grow bigger and bigger each moment, each second. So what is the impact of big data in your industry? This is a snapshot which we took from one of the McKinsey reports which was published earlier last year. This shows on what would be the impact of big data in the industries which are highlighted here. The bigger the cluster, which you could see in the graph, the bigger the impact that it would have in that particular industry. So we assume, or as per this report, again, the retail industry is one of the biggest benefactors of big data. Then manufacturing and transporting, warehousing, finance and insurance. These are some of the sectors which would be heavily impacted by the big data, and the way the organizations are able to use big data within their within their organizations. So it is and whichever industry you are in, we believe that if you are able to make use of the data which is being generated, whether it's through your own databases, whether it's through your own transactions or whatever it is, if you start early, you'll definitely have a critical advantage vis-a-vis your competitors, and you could start early and make benefits of the information or the treasure of data that we have today. So now let's talk about certain use cases from various different industry verticals on how these industries are using big data today, and how you could probably think of a use case out of this for your particular organization. Let's start with the first and the most common industry that all of us are connected to, the telecom industry. Telecom industry basically would give you, the telephony infrastructure, your mobile phones, the internet, the data in and out. And just imagine any telecom provider today will have networks which are spread over thousands of cities across a country, and in certain cases across multiple countries, across multiple continents. So for them the challenges are too many. So they'll have a few million customers typically. The challenges they face typically are the customer retention. Today I could switch my telecom provider from AT&T to Sprint to some other provider. They need to understand the payment details for the new schemes, the new data packs that they launch. They need to understand how various users are responding to those payment details. They need to understand or customize their payment service and models for the customers. They need to understand the competitor pricing, and they need to innovate fast so that they could respond to the competition in a much faster way and in a much better way. And they need to identify what offers or what plans work in a particular geography, identify what is working in a similar geography at some other in some other state or in some other country, and probably try those things out in a new geography. So there is a lot of data which they would have. Just imagine 1 million customers with making, say, 2 to 3 calls on an average on a daily basis, using a few MBs of data every day. The data that they could collect is humongous. So how is the telecom industry using big data, or what are the opportunities telecom has in big data? Here are some of the things that we could figure out. They could try out innovative business models like improving customer service by data-driven API models. They could anticipate and implement network planning even before the network reaches the stress point and the customer experience is hampered, by identifying or predicting data which they have already collected. They could come out with precise business models which would help them reduce the churning out of customers and retain their customers for a longer period of time. Finally, they could make real-time decisions. Your customer care has real-time access to the data of a particular customer, and just by giving a better user experience, anytime you're able to reach a call center guy and get better user experience and retain that customer for a longer period of time, and even improve your chances of increasing the revenue. So this is how these are some of the opportunities of big data. If you want, we will be sharing this presentation at on SlideShare and sharing the link with all of you at the end of the webinar. So you could go through all the opportunities in detail. I'll not cover each one of them right now. We'll just focus on some of the better use cases for each industry. The next industry, of course, is the retail industry. The retail industry typically or historically has been at the forefront of using any technologies, right? And for them, the innovation or the pace of innovation that they implement has to be, very fast, because they have to survive in a very competitive market. And retail industry is probably the best in the best position to make use of data and collect and analyze data and improve their bottom lines and improve their top lines as well. Why I am saying this is, I'm saying this because just imagine a typical retail chain, right? We may not talk about Walmart, but say any other retail chain. Maybe, just imagine a typical retail chain would probably have hundreds of customers, hundred of stores spread across the country. They'll have a few outlets in each of the cities, and they'll have 10,000 customers on an average visiting their store every month. They'll have each customer buying probably 5 items every month or on each of their trips to the store. They'll have a catalog, or they'll have a stock of at least 20,000 items in stock. And if you just try to add up or try to multiply these numbers, it's millions and millions of data points that they have, which they need to collect, which they in any case collect, and which if they track it correctly and analyze it correctly, that would give them the business benefit like none other. So the challenges for them, for the retail industries, have been typically to identify the buying patterns of their customers, identifying which shopping offers to roll out in a particular store, how to predict demands, how to have effective marketing campaigns, how to do dynamic price optimizations, how to retain a customer, among others. So what are the opportunities today in retail using big data? One of them is personalized recommendations, which is being used heavily by both the online stores as well as the offline stores. If you visit Amazon.com or any other e-commerce companies, typically you will see personalized recommendations for you, either based on the previous items that you bought from the e-commerce store, or if you're browsing a certain category of items or certain categories of purchases on the online store, you would get recommendations based on what other people with the same demography like you purchased when they browse such items. Similarly, you get offline recommendations as well, offline personalized recommendations in your emails, in your mails, with personalized advertising pamphlets coming to your mailbox from multiple retailers, identifying or giving you details about what items you would be interested in purchasing from your nearest retail store. So there are a lot of interesting use cases that are there in the retail industry, and you could read about a few of them. Target is probably one of the most talked about use cases. Sears has its own set of big data solutions, and the way they have used big data for their own organization. Walmart uses big data at a large scale to identify or predict demands and predict the in-store experience of or improve the in-store experience of a particular user. Inventory management is again one of those things where big data is being used heavily by the retailers to improve the efficiencies and eventually bring down the costs for their end customers. So retail, as we understand and as we've got feedback from a lot of our customers in the retail segment, is the industry which is best suited to take advantage of big data. The next industry that we talk about here is the insurance industry. In the US as of today, the insurance industries lose out on almost $80 billion just due to frauds. So just imagine if they could reduce the number of frauds or the amount of frauds that reduce the amount of money that they lose because of these frauds. Just imagine their bottom lines and top lines, how their bottom lines could improve, and eventually how they could pass on that benefits to the end customers like us. Claims on most of the automobiles, to 25 to 33% of them are fraud claims, typically. So for any insurance company, the three major questions that they have is how to tackle the increasing diseases and ailments and thereby decreasing their chances of paying out to a customer. What are the policies that are best suited for a particular demography of a customer, for a particular ethnicity of a customers, and how to improve the user experience, the customer experience, by reducing the customer hassles. So these are certain challenges that insurance industry faces today, and we'll just look at the opportunities that are there using big data on how this could be improved and implemented at any insurance organization. First of all, and the most most talked about or most implemented use case in an insurance industry is the fraud detection. Because insurance collects a lot of personal details from any customer. There are certain patterns that they could figure out. They could do cohort analytics to track social activities of beneficiary and the associated parties. They could integrate the data streams of information to detect fraud patterns from multiple customers so that they could identify a pattern and identify that this pattern matches the previous patterns of fraud, and they could stop it and do a predictive analysis to improve the fraud detection ratios. They could do predictive analysis to identify the customer lifestyle by integrating the various social networking feeds, identify the disease patterns, as I said, based on the demography of a particular customer, and then accordingly provide them with tips, or provide them with advisory notes on how they could improve their family life or how they could improve their health, and ensure that they end up paying lesser amount of insurance claims to their end customers. Again, and the final use cases that we wanted to touch upon today is the automobile industry, or the auto industry. As we touched upon earlier in the presentations, connected cars are no longer a concept; it's a reality. Any typical Ford car that you would buy today will have more than 74 sensors in it, and we've seen cars coming out with more than 100 sensors, which would track data points from your tire pressure to the fuel levels, and then collect that data, identify your driving patterns, and collect all of those data and then push it back to the automobile manufacturer, who could then use the data to identify patterns of defects in the cars that they have sold. They could identify the driving patterns and share that data probably with the insurance guys to track your driving patterns and ensure that if you're a safe driver, probably you could save on a lot of premium there. And there are a lot of other opportunities as well. So a hybrid car today probably generates more than 25 GB of data per hour when it is being driven. So let's look at the opportunities using big data in the auto industry. Vehicle insurance is probably, again, one of the biggest use case that you could think of when it comes to big data in the auto industry. Why is that? Because using telematics, you could identify the driver's driving patterns. These driving patterns can then help the insurance companies to give out alerts, warnings in real time, and even give personalized pricing for you on your premium. So if you are a safe driver, if the data collected from your car is perfect, probably you could end up saving a lot of money when it comes to paying premiums to the insurance companies. Similarly, your car's intelligence system can keep a track of all the parts and liquids that needs to be changed or updated, or it could give you an alert for periodic maintenance, which it does right now. But that data, if shared with the mechanics or the auto manufacturers, could actually add a lot of value, and which could also save you a lot of money, because if you know that a problem is about to occur, or if you could predict a problem that is about to occur, you could fix that problem before it actually occurs and before a breakdown occurs, and save a lot of money with the auto mechanic. So these were some of the use cases that we wanted to discuss from various industries. Of course, having discussed these use cases, there are a lot of other use cases which we would be happy to talk about one-on-one with each one of you. We understand that today we have people joining in from the education industry, the retail, the media, and quite a lot of other industries as well. So we would be happy to talk to you one-on-one and understand your use case, and give you or advise you on how you could make use of big data within your organization to benefit from the data that you have already collected or you will be collecting in the future as well. So coming back to the presentation, we just wanted to talk about cloud computing and why we think cloud computing is big data's best friend. And we just wanted to give you a brief overview of how with cloud computing you could use big data to save a lot of cost, A, in setting up the IT infrastructure that you have, and B, setting up highly scalable and fault-tolerant applications which could churn data at tremendous scale. So we'll just talk about that in brief. So with big data, we know we want to generate the data, we want to store the data, we want to analyze the data, and finally share it with different stakeholders so they could take the right decisions, right? So let's see how cloud comes into the picture. So when we started the presentation, we said big data is something which is difficult to process using the existing infrastructure that we have as of today, or using the existing tools and technologies that we have today. So, our IT resources typically are limited and precious, and the IT resources are not just the hardware or the software component, but it's also the people, right? People are the most precious resources that we have today. And if our database administrators or if our brightest software engineers in the organization spend their time in maintaining the application or maintaining the infrastructure or maintaining the uptime, we are losing out on a lot of talent there. So, cloud basically helps you, fix that solution, fix that issue with the solution, with these advantages, right? Cloud, as we all understand, has many advantages. It is quite scalable. It is cost effective. It does away with the capex model and focuses more on the operational costs. You can automate a lot of things on cloud. You could scale out your applications to a tremendous level, create supercomputers to process trillions of data points in a matter of few hours, which probably was out of reach for a lot of organizations just because of the capex investment that it would require. So these advantages help the end users to process data on cloud at much effective and in a much faster way and in a much simpler way. Cloud optimizes your IT resources. Because now, as I said, IT resources could be identified as human resources, the software engineers, the hardware, and the software resources. Now, using cloud, your software engineers, your database administrators could actually focus on improving the efficiencies of the database rather than worrying about taking a backup or applying a patch or worry about if the application crashes or not, and rather focus on just giving out business value to the end customer. Clouds makes it easy to use big data. Right now, if you use cloud, you could essentially just spend 30 amount of time worrying about configuring cloud, worrying about setting up the cloud infrastructure, and actually spend 70% of your valuable time, precious time, on analyzing and using big data. Cloud essentially makes it easier for you to handle the big data. It's very easy to handle big data on cloud compared to your on-premise infrastructure. So now let's talk about the big data lifecycle, right? We understand that big data lifecycle could be divided clearly in these 4 stages. The 4 stages are generation of data. The next phase is the collection of the data which is generated and storing it somewhere. The third phase or the third step is to analyze and compute or process all the data which is being collected and stored. And once you have analyzed and computed the data, you can then create excellent reports out of it, get analytics out of it, and then share that data so that everybody in your team could collaborate on the data which is being shared. So let's talk about the 4 phases one at a time. Generating the data. So how these are various ways that organizations generate data. Your data could be as simple as the structured data of your employees, your employee records, your employee master. It could be unstructured data like social media profiles of a user. It could be semi-structured data in case of end user logs, your machine logs, your web server logs, your database logs, etc. The data could come out of it could come out of log files. It could come out of your web servers, your hardware, your cars, anything, right? And you could be generating data at each and every step, at each and every second while doing a business transaction. So data can come from various different sources and in various different formats. The next is transferring of the data. So the next phase of the data is to collect the data which is generated and store it somewhere. So in this slide what we have tried to do is put in certain AWS or Amazon Web Services which could actually help you in collecting the data and then eventually storing it on the cloud. So these are the three services which which you could think of while collecting the data. The first service is called the Amazon Web Services Import-Export service. Import-Export service is basically a service which could help you migrate a large amount of data for the first time onto cloud. So it's basically moving large amounts of data into and out of AWS using portable storage devices for transport. So basically you collect the data, encrypt the data, ship it to AWS, and AWS will import the data on their own infrastructure. The next way to collect and transfer the data on cloud or on AWS is the AWS Direct Connect. The AWS Direct Connect basically is an established dedicated network connection from your own premises, from your local infrastructure, directly to the AWS infrastructure. That gives you a dedicated pipe of 2 GB, 10 GB, up to 10 Gbps for you to transfer data which is created on premise and move it on to cloud to get efficiencies of data processing. Finally, there is one more service called Amazon Storage Gateway, which is basically an integration between your on-premise infrastructure and your cloud storage infrastructure, which would essentially make your cloud storage a secondary backup of your primary data storage on cloud. So once you transfer the data, you need to store the data onto AWS or on the cloud infrastructure. So here are some of the ways that we would talk about for storing the data. The first and foremost is the Amazon Simple Storage Service, or Amazon S3, which is probably one of the most popular and the oldest service from Amazon stable. Why S3? Because what is S3? S3 is an object store. By that I mean that you could actually upload files on your S3 bucket, and you get unique URLs for each of those files. So for example, if you are a media content serving organization, you could upload a video file or an audio file and then get a unique URL to access that particular content. So now you don't need to worry about setting up hard drive or setting up a SAN storage on your premise and then maintaining the backups and everything. S3 provides good object store capabilities, and it comes with 11 nines of durability, and it is quite cost effective. Today we had the 42nd price reduction on AWS, which essentially dropped down the S3 prices by up to 65%. So now if you're storing 1 GB of data, that would essentially cost you just 3 cents per GB per month. That's very cheap compared to the on-premise options that you have for today. The next data storage options on Amazon Web Services are the databases that they provide. Now there are different types of databases that AWS provides. AWS provides an relational database service, or RDES, which basically is a managed database service which would help you run certain standard relational databases like Oracle, SQL Server, MySQL, and recently there was also support added for PostgreSQL SQL database engine. So that is about relational database service. So if you have a requirement to use a relational database and you do not want to spend a lot of time in managing or setting up the relational database, you could sign up for RDS, which would spin off, for example, an Oracle database in less than 10 minutes, and you could basically start, you could basically connect it to your application and start transacting on that database. The next managed database service that AWS provides is called DynamoDB. DynamoDB is a fully managed NoSQL database service, which makes it quite simple and cost-effective to set up and manage a NoSQL database on top of AWS infrastructure. DynamoDB has its genesis, from Amazon.com, and AWS basically took that technology out and is now providing it as a service to all the end customers across the globe. So now that we have collected and stored the data on cloud, the next requirement is, of course, or the next phase of data, big data processing is the data analysis on cloud. And when we talk about big data, we essentially, from a technology perspective, talk about Hadoop in 99% of the cases. Hadoop has today become synonymous to big data, and if in any of your discussions on big data, everybody would eventually end up talking about Hadoop. So how can AWS help you in actually setting up Hadoop infrastructure on cloud? So if you have ever tried setting up a Hadoop cluster on your on-premise database, I'm sure you would have faced a lot of issues. It's not a very simple process. It's pretty time consuming, and it's a pretty complex process as such. So how does AWS help you fixing this issue? So AWS basically has a service called Amazon Elastic MapReduce, or Amazon EMR, which is a managed Hadoop distribution by AWS using customized Apache Hadoop framework. By that what I mean is, you could essentially set up a Hadoop cluster on cloud with a click of a few buttons. You could have a master node, and you could have hundreds and thousands of slave nodes to that master node, and basically process petabytes of data in a matter of hours in real time. So using MapReduce, data processing tasks are mapped to a set of servers. So basically there would be a master server which would essentially pass on sets of data to different slaves, and these slaves would process the data one at a time and then pass back the results to the master node, which basically collates the data and then presents it to the end user. So EMR is a technology which is used heavily when it comes to processing huge amount of data. So if you are looking for setting up a Hadoop infrastructure on your premise, you should also have a look at Amazon EMR, which makes the setup process quite easy, and it works the same way, or it gives the same kind of performance as Hadoop on premise. Finally, once the data is processed using EMR, you essentially need to store that data somewhere again in the process data, and then make that data available to your end users so that they could retrieve the data, connect it with a business intelligence tool, connect it with an analytics tool, and then generate reports, generate analytics, and then eventually share that reports and analytics with different stakeholders within the organization, within the team, and make some business sense out of it. So to do that, Amazon recently, a year back, came out with a service called Amazon Redshift, which is basically a petabyte scale data warehouse on cloud. Amazon Redshift is a fully managed data warehouse service, which makes it simple and cost effective to analyze your terabytes of data on cloud. Very easy and very cost effective. Just to give you an idea of how cheap Redshift is, you could essentially have a petabyte of data warehouse storage on cloud at less than $1,000, essentially at $999 a year. If you compare that with the traditional data warehousing solutions which are available on premise, the licensing and the storage cost itself would cost you 10 times more than what Redshift comes with. And of course, with Redshift you have the advantage of having the elasticity in place. It comes with a massively parallel processing architecture, It parallelizes your queries and distributes your SQL operations across different clusters, ensuring that you get the benefit of scale, you get the benefit of elasticity on cloud, and basically you get your results faster. Finally, to connect all of these services that we talked about, right from data collection to data storage to processing and analyzing the data, there is a service from Amazon Web Services called Amazon Data Pipeline. Amazon Data Pipeline basically allows the users to define dependent chain of various different data sources within Amazon and even outside of Amazon. So if, for example, you have a database which is your on-premise database, or which is a database which is being stored in some other cloud, you could basically create an Amazon Data Pipeline workflow and interconnect all of these data sources, all of the data processing tools and techniques, tools, services, and you could create processing activities to simplify the management of data that you have. Right? Data pipeline could be implemented across all the stages of your big data lifecycle. It supports a lot of input and output nodes like S3 bucket, DynamoDB, MySQLDB, Amazon RDS, EMR. You could even run your shell scripts using Amazon Data Pipeline, etc. So if you want to simplify your data management on AWS, you should definitely have a look at Data Pipeline. Finally, just a couple of months back, AWS came up with a new service called Amazon Kinesis, which is big data in real time. By that I mean, what I mean is that it's a fully managed service for real-time processing of streaming data. So now, for example, think of a scenario where you need to, you are a media company and you are broadcasting a show live on television, and there are millions of users who are tweeting about the show, or millions of users who are tweeting, for example, about a game which essentially happens during Super Bowls or NBA finals. You need to collect all of those data and in real time, and process the data in real time, and then probably come up with certain analytics which would help you in improving your coverage in real time. So you could Amazon Kinesis basically would help you in doing that. So traditionally people have used tools like Storm and Kafka, which does the same thing, but with Kinesis you could do it in a much easier and a simpler way, because it's a managed service and because it is quite scalable, and of course it's quite cost effective. And the data that you collect using Amazon Kinesis could be directly dumped into the Amazon DynamoDB or Amazon Redshift and even Amazon RDS databases to ensure that you collect the data and you could start doing all the analytics and processing on top of it. So this basically completes the big data lifecycle of. We've tried to cover all the 4 phases of big data lifecycle and how various different AWS services help you in connecting all of these lifecycle phases of big data. I hope it was it was useful for all of you. We've just tried to create a snapshot on what services could be used in which phase of big data. Having said that, certain services could interchange the phases, and you could use certain services outside of AWS as well for managing your big data. So with that, we come to an end of this presentation. Before we conclude, I just wanted to give you an overview of BlazeClan's capabilities on big data and on Amazon Web Services. So we have recently developed and launched a product called Cloudlytics.com, which is basically a software as a service log analytics tool completely powered by AWS. And this is a simple architecture that we have, simple data flow that we use currently, wherein we collect different logs for different customers, put it into an S3 bucket. We process the data using Amazon EMR and a couple of NoSQL databases, which would do certain data transformation. And finally, we put that processed data into Amazon Redshift. And once you put the data onto Amazon Redshift, we have our own BI tools, which gives a lot of different analytical reports to our end customers. helping them identify the usage patterns of their end customers. So the tool basically processes Amazon CloudFront and Amazon S3 logs and gives out a lot of different insights and analytics to a CloudFront user on how their content is being consumed by their end customers. Right. So that's the end of the presentation. I hope everybody and everybody had some takeaways, good takeaways from the presentation. I'll just hand it over to Anuj, who will take up the Q&A one-on-one with everyone. So if you have any questions, just type it into the chat box that you have at the bottom of the webinar screen, and we would be we'd be happy to answer whatever questions we could in the limited time that we have left today. Thank you, guys.
Thank you very much, Varun. Yeah, so I'll take a look at the Q&A, but just to kind of give everyone a brief again. Big data does have an individualized organizational ROI. So if there's something that you want to discuss about, don't hesitate to reach out to us to understand how there's a value proposition to any given organization. Whether large or small, there's various pieces of structured, unstructured data that you may or may not be bringing in together. So I think at the end of the day, we can chat one-on-one about that. But as always, we're always here to kind of engage. So just one overall question that seems to be asked quite a bit about big data, and Varun, you can kind of you can answer accordingly. But generally, if there's any organizational advice that you can give, where does an organization start from a big data an assessment perspective?
Okay, so the question is how does an organization, or where does an organization start, or when does an organization know that they have a big data problem in hand, or if they could, how they could make use of big data basically? Is that the question?
Absolutely.
Right. So, if you are an organization which collects data from multiple different sources, it may or may not be huge in volumes, but say for example you have data which is generated at quite a lot of velocity, and data which comes in various different formats or variety, which you could probably not put it into a single database or a relational database rather. Then you should think about the ways to process the data and put it into a uniform format into some data store, so that you could you could do analytics on top of it. Of course, the second place where you definitely know that you have a big data problem is the volume of data that is being collected by multiple different sources from within your organization or from other sources outside your organization. So basically, if you have huge volumes and if you have variety of data which is being generated, you should think about using certain tools related to big data, and you should explore the opportunities that are available on big data. Of course, yeah. So these are the technical things. If you with the volumes, if you have a lot of data which you think if you analyzed it correctly would help you in getting certain business benefits, which would help you in improving your top line or bottom line, you should think of processing that data right away and getting meaningful insights out of it.
I appreciate everybody's time. If there's anything that you need us to continue to answer, you can send a broadcast email to info@blazeclan.com. If not, you can reach out to our contacts directly on the website as well. And please do not hesitate to check out blazeclan.com/webinars. We do have kind of an ongoing list of various education pieces of various sides of the Amazon Cloud Services, and then obviously the BlazeClan business models. So don't hesitate to reach out to us and to register yourselves for ongoing and future webinars. Thank you very much again for everybody's time, and have a great day.
Thank you, everyone.
Sorry, there's actually one question that just came in, Varun.
Okay.
any good sites on tutorial for Hadoop? So maybe a Hadoop educational site. Maybe do you have any recommendations for the audience in terms of where they can get more tutorials and education on Hadoop?
So on Hadoop, there are a lot of different sites. The most referenced about big data or Hadoop tutorial site is probably Cloudera, which you could, Cloudera is again one of the customized versions of Hadoop, but they have very good insights and very good tutorials on big data and on how to implement Hadoop, how to start with Hadoop, and how you could basically write programs or jobs in Hadoop. So you should explore cloudera.com. Apart from that, you could also visit our blogs where we keep on posting about big data and Hadoop frequently. So there would be a lot of content that you'd find on blog.blazeclan.com as well.
Great, Varun. Thank you very much, everybody, for your time again. And once again, stay educated, attend our webinars, and if there's anything else that we can do to assist you or your organization proceed with any of your cloud or big data projects, don't hesitate to reach out to us. Thanks, and have a great day, everyone.